Okay, points A at -1, 0, point B at 0, 3, and point C at 4, 0 are connected to form a triangle. Based on the triangle's side lengths, what is its correct classification? Equilateral, scalene, isosceles, or a right triangle? All right, I'm going to show you a tool that you could possibly use. It's called GeoGebra. And click on click on Classic. And we're just doing geometry. So if you click on the circle triangle with the 3 faded gray lines, you notice it'll show or hide a grid. You can show a grid. And then we can plot some points. And if you click this, show or hide the axis, you can show and hide the axis. So what I'm showing you is a way to use a tool to help answer this question. So again, it's GeoGebra, it's classic, it's geometry. You click these ones and click the grid and the axis, and it'll set it up for you. And the reason I'm doing this is because I want to use something that is going to help me to quickly solve this. So point A is located at -1, 0, so I'm going to go at -1, 0, and I'm going to click this name, so it does name it, and then I'm going to click at 0, 3 for point B, and I'm going to click at 4, 0 for point C. So here's the outline of that triangle. The next thing I'm going to do is click Segment, connect them. So I'm just selecting each one. So now we have this triangle based on the triangle's side lengths. So I want to know the side length of this. If you click on this angle, notice it says distance or length. So click on A, click on B, and it'll show you that distance. Click on B, click on C, it'll show you that distance. Click on C, click on A, it'll show you that distance. And I'm showing you this because it is a tool to help you find it. We can also do it using the distance formula. So if you are to remember, side lengths are 3.16, 5, and 5. So is it equilateral, scalene, isosceles, or right isosceles? So again, if you aren't remembering the options, use your key terms. So there was isosceles, a triangle with at least 2 congruent sides. This does have 2 congruent sides. The other option was a right isosceles, so that means we have to check to see if the angles are 90 degrees. One way you can use this tool is click on where we did the distance or length, click on angle, click CAB, that'll tell us this angle. ABC will tell us angle B, and BCA will tell us angle C. And if you can see them, I'm going to move them. We have 71.57 and 36.87. So no, it is not a right isosceles triangle. It is an isosceles triangle though. It is not equilateral because not all of the sides are the same. So that's one tool you can use in order to solve this. Another tool you can use is just the distance formula. So again, remember, distance is equal to the square root of your horizontal distance being squared, being squared, plus your vertical distance being squared. Now that's the conceptual distance formula. The horizontal distance is represented by x sub 2 minus x sub 1, and vertical distance is found by the second y coordinate minus the first y coordinate. So that is the conceptual way to remember your distance formula, and there's the algebraic way to remember your formula. If we were to use this, we would just know our points, and we would have A is at -1, 0, B is at 0, 3, and C is at 4, 0. So in a triangle, if you're just visualizing it roughly, we have A, B, and C. Let's pretend that that comes to a point. So there's A, B, C. So remember that we have side lengths AB, we have a side length B to C, and we have a side length A to C. So we have side length AB, side length BC, side length CA or AC. So let's first find the side length for A to B. So I'm going to be looking at these first two coordinates. I'm just going to list A as x1, y1, and B as x2, y2. So that when I do my horizontal distance, it's going to be x2, which is 0, minus x1, which is -1, and the vertical distance is going to be y2, which is 3, minus y1, which is 0. So then we're going to use a calculator and jump over here. We can just type in the square root of parentheses 0 minus minus a negative does come out to be plus, so we can on this plus 1 in parentheses and you square it, plus 3 minus 0 in parentheses and you square it. So you hit this button to square it and you would close your parentheses. That comes out to be AB is equal to 3.16. So then you would do that for the distance of B to C. So we would have the distance of B to C now. And now our x1, y1 changes. B is listed first, so there's x1, y1, and x2, y2. So when we find our formula, it's going to be x2 is 4 minus x1 is 0. Y2 is now 0 minus y1 is 3. So when we come over here, we're going to hit square root, parentheses, 4 minus 0, close those parentheses and square it, plus parentheses 0 minus 3, close those parentheses and square it, close your parentheses. That comes out to be 5. And then the next one is going to be the side length of AC. And again, our labels are going to change. A is going to be our x1 because it's listed first, y1, and C is going to be our second one, so x2, y2. So now when we do this, we have x2 is 4 minus x1 is -1. Again, minus a negative reduces down or simplifies to an addition. Y2 is 0 and y1 is 0. So now we have the square root, and I'm going to think here for a second. Well, 0 minus 0 is 0, so I really am not going to write that because it's nothing. 0 represents nothing. So we have 4 plus 1 being squared plus 0. So that's equal to 5. So AC is equal to 5. Again, if you notice, we ended up with the same side lengths, 5 and 5 and 3.16. So there's two different tools that you can use in order to solve for this question. I showed you both. If you want to use the GeoGebra, that's totally fine. Please just rewatch the beginning of this video and step through it or play around with GeoGebra till you figure it out. So that's how the tools that I would use to help for this one.